Challenge. Bismillahirrahmanirrahim. Let us start. This time we'll start with the clipper circuits and the clamper circuits. These are two very interesting circuits that are able to change the wave shape of the input signal. First is Article 2.8. This is the clipper or the clipper circuit. We have two categories. First is the series clipper and second is the parallel clipper. Initially, we will discuss the series clipper, and in later slides, we will discuss the parallel clippers. So this circuit that we see, the first circuit that we see is the series clipper circuit. It consists of a simple diode and a resistance, and the resistance at one side it is connected to the cathode terminal of the diode, and the other terminal of the resistor is connected to the ground. Now these circuits, they are capable of doing two things. First, they will remove the unwanted part of the signal, that is that part which is reverse biased. And second thing that they can provide is they can increase or they can decrease the voltage level. Okay. So first of all, if we look at the first input voltage, this is the square wave from 0 to pi or half cycle. The signal is positive V. Then from pi to 2 pi, or for the remaining part of the half cycle, the input voltage is minus V. When such voltage is provided to the input of the clipper circuit will simply remove the reverse biased or the negative part of the input signal with respect to the direction of diode connected. So with the diode connected as shown in the figure, only the positive part of the input voltage will pass through the diode, and it will be available across V out, whereas when the V appears across the input, when this negative voltage appears across the input, the diode will reverse bias and the signal will not pass through the resistance. So what will happen that from 0 to time pi or time t by 2, where we have positive V, this positive V will pass through the diode, because the diode, it will allow forward bias, it will allow the positive voltages to pass through it, and this voltage will be available across V out. However, for the remaining part of the signal, that is from pi to 2 pi or from t by 2 to time t, where we have minus V as the amplitude, this minus voltage will be blocked by the diode in the direction as shown. Hence, the output voltage will be 0 from t by 2 to time t. Therefore, the clipping action is that in this case, the negative part of the input signal has been clipped, has been removed, or it has been eliminated. This was the first example. This was the first initial discussion on the clippers. Now let us look at another example. That is, let us take a triangular waveform. The triangular waveform has a positive voltage from 0 to time pi, and the triangular waveform has a negative voltage from time pi to time 2 pi. So when this signal is provided to the input side with the direction of diode shown, only the positive half of the input signal will be available. Only the positive half of the signal will be available at the output. However, that is from 0 to pi. We will have a positive voltage, which will be again it will be a triangular waveform. But when the negative part of the triangular waveform appears across the input, this negative part with respect to the direction of diode connected, it will be blocked. It will not be allowed to pass through the diode. The diode will act as a open circuit, and hence the output voltage will be 0 because the current through the resistor R is 0 amperes. Therefore, the output voltage will be 0 from time pi to time 2 pi for the negative half cycle.
Excuse me, sir.
G.
Sir, is there any diode available which can emit forward biased part and we can have reverse biased part?
Well, that can be done if we totally eliminate the diode and replace a copper wire instead of the diode, so that we have both the halves available.
Sir, we want to have only negative half cycle.
If you want to have the negative half cycle, then what we can do is that we simply reverse connect the diode as shown. We remove the diode with positive connected at the anode and replace it with the diode with now this time the positive is connected to the cathode terminal. By doing so, when we apply the same input voltage, what we will get is this time what we will get is we will get a voltage that is 0 from time 0 to time pi, and then from time pi to time 2 pi we will get a minus, we will get the negative part of the input voltage. So this will be done when we reverse the connection of the diode. Was this your question?
Sir, it means that there are
Yes,
two
sir.
types of clippers. One is positive and second is negative.
Well, if we look deeply, the concept is the same. All that we have done is we have just reverse connected the diode. So the same theory will be applied. If we connect the diode in one direction, then only that part of the voltage during which the diode remains forward bias, only that part of the voltage will be passed, and the other half will be blocked. And if we now change the direction of our diode, then the reverse will happen. ठीक है?
Sir, if we
जी.
use forward bias, then we get a positive half cycles. Then what is a clip, positive or negative?
When we, yes, okay. When we connect the diode, like as shown in the original diagram, with the anode terminal being connected to the battery and the cathode terminal being connected to the load, what is being clipped, what is being removed is the negative part of the input signal. This negative part of the input signal has been clipped away. It has been eliminated. It has been removed from the output. So the clipper has removed the negative part of the input voltage when the diode has the anode connected to the battery and cathode connected to the output. Now, secondly, if we change the direction of diode, that is this time if we cancel the original circuit configuration and add a diode in the opposite direction, such that the cathode is this time connected to the input signal and the anode is connected to the output load. Now what will happen? This time the positive part of the input signal will be removed. It will be eliminated, it will be cancelled, and the output will only have the negative voltage available, whereas the positive voltage has been clipped away. It has been eliminated due to the direction of the diode. So the theory, the theory will remain the same. What we have done is we have just seen the possibilities of connecting the diode in two possible directions. ठीक है?
Okay, sir. But the clipping time period from the 0, or in case of diode 0.7, in case of silicon or germanium 0.3.
Yes, that is understood, that when the diode is forward biased, we will have a voltage drop of 0.7. But as we have discussed in an earlier lecture, that if the input voltage is very large as compared to 0.7, then we can use the ideal model of the diode. In that case, we will ignore the 0.7 voltage drop. But if the input voltage has a amplitude which is comparable to 0.7, in that case, V out V in minus 0.7 volt in case of silicon, or V in minus 0.3 volt in case of germanium. ठीक है?
Yes, sir. लेकिन बट सर क्लिपिंग की सही समझ नहीं आई कि जब हम पॉजिटिव सिग्नल लेते हैं तो हमें पॉजिटिव सिग्नल क्लिप होना चाहिए ना सर?
No, clip means to eliminate. Clip means to cut off. So in what we have done is that why we call this circuit a clipper is because this circuit is removing one certain part of the waveform. And that certain part depends on the direction of diode connected. So this is the meaning of clipping.
Okay,
And
sir.
such circuit is called the clipper.
Okay, sir.
And sir, if we connect two diodes in parallel with the opposite direction, will they act as a single wire?
Well, this question was dealt in an earlier lecture also, that if we connect two diodes, if we remove this diode and connect two diodes like so, then one diode will be forward biased and the second diode will be reverse biased.
No, sir, they are in parallel. They are in series.
Okay, in parallel, if we connect two diode in parallel, so one diode is connected as shown in the black line, and the parallel diode is connected like this. You mean like this?
Yes, sir.
So what will happen is that now both of the halves of the input voltage, either positive or negative, they will be available at the output. The positive, if we label them, we call one first diode D1 and we call the second diode D2. Then D1 will conduct when we have a positive input voltage. Diode D1 will allow positive half of the input voltage to be available at the output, whereas D2 will allow the negative half of the input voltage to be available at the output. So in this case, what we get is we get V output exactly the same as V input. Therefore, two
And
diodes
sir,
connected in parallel connection are just like as if we connect a copper wire between the input and the output, because we are now allowing both signals, positive signal and the negative signal, to be available at the output. So it would be better if you just use a simple copper wire.
okay, sir. So, sir, what will be the output of that?
The output will be as shown in this diagram. This is the output. ये है जी output.
And sir, will it be decreased by 0.7 by magnitude?
Again, the answer is the same, that if the input voltage is comparable to 0.7 volts, then yes. But if the input has a very large value as compared as the output, then we can ignore the 0.7 voltage drops of the diode. So in fact, if we want to have both halves available at the output, then it is better not to use diodes, because the diodes, they are just limiting they will limit the current. They will also add some voltage drop.
And sir, if we replace diodes by the batteries of 0.7 and 0.7 respectively, then sir, can we do the source transformations over here?
Can you repeat your question?
सर अगर हम इन दोनों डायोड्स को इन बैटरी से रिप्लेस कर दें 0.7 वोल्ट्स की बैटरी से, तो क्या हम इस सर्किट पर सोर्स ट्रांसफॉर्मेशंस कर सकते हैं?
Source? Why do you want to do source transformation over here?
हमारे पास दो सोर्स आ गया ना, तो हम इसको एक सोर्स में तब्दील करना चाह रहे हैं.
Well, I don't really understand your question, but just the diode with a 0.7 power supply is not enough. We will have to also take care of the direction of a current being allowed to flow. Therefore, the 0.7 volt power supply, which represents the barrier potential of the diode, along with the ideal direction of the diode, will now be required. Only then, when these two conditions are fulfilled, then you can apply source transformation and see and get what result that you are looking for. Okay, now let us come to the another application of clippers. This time, what we do is we add a certain amount of DC voltage. We add a certain amount of DC voltage in series with the diode, and then let us see what happens to the output voltage signal. So in the second diagram, what we have is we have a sine wave being applied at the input voltage. This V in is a sine wave, and then we connect a DC power supply. This V is not the barrier potential of the diode. In fact, it represents an external DC power supply. Such circuit is also a clipper, and this circuit will now not only will it remove unwanted signals, part of the signal, it will also change the voltage. It will also provide us level shifting. So this was that, as we talked earlier, the other capability of the clipper circuit, and this we will do in the next slide. So the next slide is in fact an example. Example 2.18. Determine the output waveform of the sinusoidal input of figure 2.74. So what we have in figure 2.74 is that we have V input. We have a V input, which is a sine wave. The peak voltage of the sine wave is 20 volts. The total time period of the sine wave is time t. And then we are using one external DC voltage of 5 volts. This 5 volt is an additional DC voltage connected in series with the diode, such that the positive terminal of the DC voltage, that is the positive terminal of the 5 volt battery, is connected to the anode terminal of the diode, and the cathode terminal of the diode is connected to the resistor R. The voltage across resistor R is made available as the output. So we want to study what is the output voltage waveform. So the solution is, in fact, it is the process how to analyze clipper circuits. And the solution has been divided into a number of steps. The same number of steps and the same sequence of steps we will apply to analyze any given clipper circuit. So step number 1 is that the output is again directly across resistor R. Yes, so output of the voltage is taken across the voltage R. The positive region, step number 2 is the positive region of V in, that is this part, and the DC power supply are both applying pressure to turn the diode on. So this line means that with the direction of input voltage V in added with the DC direction of DC voltage power supply 5 volt, they all want to turn on the diode with the direction of diode connected as shown. The result is that we can safely assume the diode is on for the entire range of positive voltages of V in. So when V in is in the positive half with the direction of diode connected, the voltage, output voltage will be as same as the input voltage with addition of the DC power supply, because diode is forward bias. So during the positive half, we can safely assume that the diode will be forward bias, and the voltage will be available across the output. Once the supply goes negative, it would have to exceed the DC voltage of 5 volt before it could turn the diode off. So when the input voltage is in the negative half, we will still have a forward bias diode until the input voltage exceeds the DC supply of 5 volt. And when the input voltage V in exceeds the 5 volt DC power supply, the diode will become reverse bias. And this we will see in the next slide. In the next slide, we have the transition. We have step number 3. The transition model is substituted in figure 2.75, and we find the transition from one state to another will occur when V in plus 5 volt is equal to 0 volt, or when V in is equal to minus 5 volt. So let us start with the transition, that we have the sign input voltage, and we are first in the positive half, and this is 20 volt. So let us take various times. This is time t1. This is time t1. What is the output voltage at time t1? The input voltage, however, is 0 volt plus 5 volt of the DC power supply. This 5 volt makes the diode circuit forward bias, and output voltage is output voltage क्या होगा? So the output voltage is 5 volt. The output voltage is 5 volt. Now let us take another time as time t2, and at time t2 the input voltage is 10 volts. So what will be the output voltage at time t2? The output voltage will be the sum of the input voltage plus 5 volt DC, and input we have 10 volts because we are at time t2. ब्रैकेट में मैं लिख देता हूं time t2, whereas we have a fixed 5 volt battery. Therefore, the voltage appearing at the anode terminal of the diode is 15 volt. And since we are taking a ideal diode, the diode voltage drop is 0 volt. It is simply short circuited. It is simply forward biased. Therefore, at time t2, the input voltage plus the 5 volt will give us 10 plus 5, 15 volts. Like this. So this is what will happen at time t2. Now let us look at what will happen at the maximum time t3. At time t3 we have 20 volt. So this 20 volt is now available at the input. This 20 volt plus 5 volt of the DC battery will give us a increased voltage. This is time t3. And then at time let us take time of t4. Time t4 is at pi. Time t4 is taken at time pi, where the input voltage is 0. So when the input voltage returns to 0, we will have the voltage appearing at the diode positive terminal equal to 5 volt. Hence, the output voltage will be again 5 volt. It will be again 5 volt at time t4. Okay. So after time t4, let us take another time which enters into the negative part, of the input voltage. And let us take this as time t5. At time t5, the input voltage is minus, let us take it as minus 5 volts. So at time t5, this is time t5, where input voltage is minus 5 volt. What we have is that we have the V in equal to minus 5 volt. This minus 5 volt in series with the positive 5 volt will create a 0 volt at the anode terminal of the diode. Therefore, the net voltage being applied to the diode is 0 volts. Hence, at time t5, the output voltage is 0. And then let us take another time as t6. At time t6 again, the input voltage is minus 5 volt again. So again, when the input voltage is minus 5 volt and added with in series with the positive voltage, we get a net voltage of 0. Therefore, from time t5 to time t6, this is time t6, the output voltage remains 0 volts. But if we take a time after t6, for example t7, where the input voltage is now 0 volt, is now 0 volt. This input voltage being added with the series 5 volt will produce output voltage of again. So by this way, we have clipped away only 15 volts of the input voltage. We have clipped away minus 15 volts of the input voltage. So this is the clipping action in this circuit where we added a external DC voltage. The clipping action was done by clipping away minus 15 volt of the input voltage. So not only have we removed a portion of the negative signal, that is minus 15 volt, we have also level shifted the waveform. And this level shifting can be observed at time t3, where the input voltage is now 25 volts. And this is the level shifting. It is occurring at time t3. In fact, it is occurring throughout the waveform. But the concept of level shifting is that we level shift the input voltage by the help of an external DC power supply. So this, as we had talked earlier, that these are the two jobs of the clipper. That it has done that, as shown in this diagram, that it has removed the negative part of the signal. It has clipped away the negative part of the signal. Along with it has level shifted that portion of the forward of the positive half, which is in series with the DC external battery. And again, we can always adjust the output voltage if we want to consider the voltage drop of the diode, 0.7 volts or 0.3 volts. So yes, this is the, again, what we have done in the next slide. The step 4 is that in figure, step number 4 is that in figure 2.76, a horizontal line is drawn through the applied voltage at the transition level. The transition level is defined by the value of DC voltage added. For voltages less than minus 5 volt, the diode is in the open circuit state and the output is 0 volt, as shown in the sketch of Vout. Using figure 2.76, we find that for conditions when the diode is on and the diode current is established, the output voltage will be the following, as determined by Kirchhoff's voltage law, that is Vout is equal to Vin plus 5 volt. This formula is our general expression for determining the Vout voltage. And if you want to find the accurate, we can always add the minus 5 volt of the voltage drop of the battery. Hence, what we see is that for the positive half of the battery, the input voltage has been level shifted. That is, input starts at 0 but our waveform starts at time t is equal to 0. It starts at time at 5 volt, and then it reaches to a maximum of 25 volt. It has been level shifted. Then even at time t by 2, where the input voltage is 0, since we have an external DC battery, this DC battery will now supply the voltage, and at time t by 2 and at time t by 2, the input voltage is 5 volt. And the clipping action can be observed from the time where input voltage exceeds minus 5 volts. And this is observed during the time where the output voltage is 0. This is a place where the input voltage has been clipped away. It has been removed from the output voltage. Then when the input voltage is less than the when the input voltage is less than the DC power supply, the signal is now available. The small signal is now available from time t to onwards. ठीक है? So any questions so far?
Sir, can you please come to the previous slide?
ये लें.
सर ये जो डीसी वोल्टेज सोर्स है 5 वोल्ट्स, सर आपने इसकी पोलैरिटी डिफरेंट कर दी थी इससे पिछले वाली स्लाइड में थी.
ये स्लाइड 4 आप देख रहे हैं.
सर इससे पिछले वाली स्लाइड में बैटरी की पोलैरिटी डिफरेंट है.
ये स्लाइड 4 है, ठीक है.
Yes,
और ये स्लाइड 3 है. तो वही डायरेक्शन तो वही है बैटरी की.
ओके सर.
तो डायरेक्शन वही है, ठीक है. So after this we will come to another example. This is example number 2.19. Find the statement is find the output voltage of the network explained in example 2.18 if applied signal is the square wave of figure 2.7. So now we have almost the same circuit, but this time the input voltage is a square wave such that Vin is 0 volts from time 0 to t by 2 and Vin is minus 10 volts from time t by 2 to t. So from time 0 to time t by 2, the input is 20 volt, and then from time t by 2 to time t, the input is minus 10 volts. We give this input voltage to the same circuit, and now we want to look at the obtained output. What will be our output voltage? Again, we are using the similar clipper circuit where we have the 5 volt DC battery connected as shown, and then we have a diode with a node connected to the positive terminal of the 5 volt battery and cathode terminal connected to the output of the resistor, and the second terminal of the resistor is connected to the ground. So what will happen? This example is quite easy because we have fixed 20 volt or minus 10 volts. From 0 to time t by 2, the input is 20 volt. Therefore, figure 2.78 represents the circuit when input voltage is 20 volt, positive 20 volt. When the input voltage is 20 volt, from time 0 to t by 2, we will have a circuit similar to 20 volt battery connected in series with the 5 volt battery. The output is what? The output is available over here. The output is 25 volts. ठीक है? So output will be 25 volt because 20 plus 5 gives us 25 volt. And this 25 volt will be available from time 0 to time t by 2. But then after time t by 2, we have input voltage equal to minus 10 volts. From time t by 2 to time t, the input voltage is minus 10 volts. So this is represented in figure 2.79, where we are using a battery of 10 volt such that the positive terminal is connected to the ground and negative terminal is available for the circuit. The negative terminal of the 10 volt power supply is connected to the negative terminal of the 5 volt battery. Now, if we look at this circuit, what is the voltage being applied to the anode of the diode? With respect to this ground, if we make a node over here and we call this node A. So what is the voltage at node A with respect to the ground?
20 volts, sir.
What is the voltage at node A?
That will be minus 5.
The node voltage at node A will be minus 5 volts. This minus 5 volt is available at the cathode this minus 5 volt is available at the anode terminal of the diode, and this minus 5 volt makes the diode reverse bias. When the diode is reverse bias, the diode will be open circuit and zero current will pass through the resistance and the output voltage will be 0 volt. This 0 volt is now available from time t by 2 to time t. ये समझ आया सबको? ये क्या हुआ यहाँ पे? How did we get this minus 5 volt?
Two batteries are in opposite direction to each other or
Yes,
have
sir.
a different polarity.
Sir, it
Yes,
will
so
reverse the polarity.
we simply added two batteries in series, and it so happens that one battery is reverse connected. Therefore, we take the net voltage, which is minus 10 plus 5 volt, which is minus 5 volts. Minus 10 plus 5 volt equal to minus 5 volt. This is the net voltage available to the diode. Therefore, this minus 5 volt is this minus 5 volt will reverse bias the diode, and zero current will pass through the diode. And when this zero current or when no current passes through the resistor, output voltage will naturally be equal to V is equal to I into R, which will be 0 volt. Therefore, from time t by 2 to time t, we will have an output voltage of 0 volt. So the net result is, the total result is, if we examine from time 0 to time t, what have we achieved with the circuit shown? We have achieved from 0 to t by 2, we have achieved positive 25 volts. This is the level shifting part. And then we have achieved 0 volt from t by 2 to t. and this is the clipping part of the clipper. ठीक है? Any questions up for this example?
Sir, in figure 2.78, what is the Y representing across the diode?
Yes, in figure 2.78, this wire represents our ideal diode when it is forward biased. This wire,
Okay, sir.
this wire represents our ideal diode when the ideal diode is forward biased. And if we look at figure 2.79, we see a cross through the diode. This cross means that this diode is not conducting. It is not allowing current to pass because of the net voltage applied across the anode terminal. It is open circuit. So it is equal to a so yes, so it is equal to an open circuit. ठीक है?
Yes, sir.
Now, yes, as we had discussed that there are two types of clippers. We have done the series clipper. Now we are coming towards the parallel type of clippers. So here we are with the parallel type of clippers. In the parallel type of clippers, we have interchanged the location of the resistance and the diode. In series clipper, the diode was connected in series with the input voltage. However, in our new parallel circuit, the resistance is now connected in series with the input voltage, and whereas the diode is now connected across the output voltage. The diode, one terminal of the diode is connected to the output terminal, and the second or the cathode terminal of the diode or second terminal of diode is connected at the ground terminal over here. So this gives us the parallel configuration of the clipper. So what will happen, or how will the parallel clipper work? We see V input, which is applied at the input terminals. The input voltage is such that it is positive V from time 0 to time t/2 or any time. It is positive V from time 0 to time t/2, and then from time t/2 to time t, it is a minus voltage. So what will be the resulting output voltage look like? First, let us provide the positive V from time 0 to time t/2. When we give positive voltage at the input, this positive voltage will allow a current to pass through the diode, through the resistor, through the diode, and then into the ground. And when this current passes through the diode being forward biased, it will produce an output voltage of 0.7 volt in case of diode or 0 volts in case of ideal diode. So this is what will happen when we provide positive voltage at the input. The positive voltage will forward bias our diode, and the diode will produce a very small voltage, 0.7 volt in case of practical diodes or 0 volt in case of ideal diode. and output voltage from time 0 to t will be 0. And this 0 volt is due to the forward biased diode. Okay? This up till now we have discussed what will happen when we give a positive voltage. Now in the next part we will discuss what will happen when we give a negative voltage. This negative voltage will be applied from time t by 2 to time t, and we have a negative input voltage. So from time t by 2 to t we give a negative voltage, negative V. What will this negative V do to the circuit? Will any current pass through this circuit when we give a negative voltage? So no current will pass when we have a negative voltage. No current will pass. The diode will become reverse biased. It will become an open circuit. No current will pass through the resistor. Therefore, voltage drop across the resistor is 0 volt, and all of the input voltage are now available across the output, are now available at the output, with the diode being reverse biased. So what we have done is that we have made available the input voltage, that is the minus voltage, be available at the output. So in this circuit, we have clipped away, we have removed the positive portion of the input signal. In this circuit, we have removed the positive portion of the input signal. Now in the second example, we have a triangular waveform. In this second example, we have a triangular waveform which is being applied to the input voltage. The triangular waveform has a positive half from 0 to time t by 2. It has a positive half, and it has a negative half from time t by 2 to t. So again, the theory, the working principle will be the same, that from time t by 2 to time t, we give a positive part, we give the positive part of the triangular waveform from time 0 to time t by 2. This positive part of the voltage will forward bias the diode, will have a 0 volt across the forward bias diode, and across the output voltage from time 0 to t we will have a 0 volt over here. So the output voltage is available, that is over here, it is simply 0 volt. And then for the remaining negative half, we have from time t by 2 to time t, we give a negative triangular waveform at the input voltage. T by 2 to time t, we give negative half. This negative voltage will reverse bias the diode. The diode will not work, it will be open circuit. And when the diode is open circuit, 0 current passes through the resistor R, and thus the output voltage will be equal to input voltage, and therefore we have a output voltage which follows the input voltage, or which has a waveform very similar to the input voltage. So again, the parallel clipper has clipped away the positive portion, whereas the negative portion of the input voltage is available at the output. ठीक है, any questions so far? Any questions up till now?
सर ये पॉजिटिव हाफ साइकिल के लिए दोबारा बता दें जरा।
ठीक है, ये पॉजिटिव हाफ ट्रायंगुलर के लिए क्या स्क्वायर वेव के लिए?
सर ट्रायंगुलर के लिए।
ट्रायंगुलर के लिए, चलें ठीक है। So let us look at the triangular waveform. Let us look at the triangular waveform. It is our input voltage. This is the input voltage that we are applying to the input of the parallel clipper. The triangular waveform has two parts. One is the positive part, one is the positive half, and second is the negative half. First, from time 0 to time t/2, we have the positive half. So let us analyze this part by part. That is what will happen during the positive part. From time 0 to time t/2, we have the positive part. ये clear है सबको? And let us assume that the triangular waveform starts at time 0 and then at a certain time it reaches its maximum voltage of positive V volts. For example, I am taking for example positive 10 volts. Okay, so and then from the maximum positive 10 volt to t/2, the triangular waveform follows a negative slope, and at time t/2 the input voltage approaches 0 volts. Now we would like to study what happens during the positive half, but we must also recognize that with the direction of diode connected, the diode will allow current to pass when the voltage at its anode is larger than the voltage at its cathode. And this is exactly what is happening over here. The input voltage is larger at the anode terminal compared to the cathode terminal. Therefore, we say that a current will pass through the diode because it is forward biased. यहाँ पे ये पॉजिटिव है, यहाँ पे ये नेगेटिव है. This makes our diode to be forward biased. And when the diode is forward biased, first of all, we will have a voltage drop across the diode equal to 0 volts. तो हम ये कह देते हैं कि आउटपुट पे, अगर हम ये आउटपुट पे देखना चाहें, तो आउटपुट 0 to t/2 is 0 volt because here what is happening over here? Diode D is forward biased. Diode is forward biased from time 0 to t/2. Then input पे अगर आप, let us assume that we have reached 10 volt. अगर डायोड पे 0 वोल्ट तो फिर ये 10 वोल्ट कहाँ कंज्यूम हो गए? ये जो 10 वोल्ट्स आए हैं इनपुट पे, ये किधर कंज्यूम हो गए हैं अगर डायोड के अपने 0 वोल्ट्स हैं?
रजिस्टर में.
So applying Kirchhoff's voltage law, all of the voltage at the input will be dropped across the resistor R, because we have the forward bias voltage of the diode equal to 0 volt. So all of the voltage rise at Vin will be available across resistor R throughout time 0 to T by 2. Okay. Then after this, after we okay. After T by 2, let us come to the negative part of the input signal. That is when the input signal is in the negative region. That is from time T by 2 to time T. The input voltage will be in the portion and have a V volts, or we can assume minus 10 volts. So first of all, what will happen that our diode will be reverse biased. Diode will not conduct. Diode will not work. It will be reverse biased. And when the diode is reverse biased, zero current will pass through resistor R, and all of the voltage available at the input will now be available at the output. Therefore, the parallel clipper will allow the negative portion of the input voltage be available at the output. And this is happening due to diode D is reversed biased. ठीक है? ठीक है, फिर चले आगे.
Yes, sir.
चलिए. So now let us come to example number 2.20. Example number 2.20. The statement of example 2: determine output voltage for the network of figure 2.82. Here we have figure 2.82. The input voltage is a triangular waveform with peak of 16 volt and a negative peak of again minus 16 volt. So let us study the circuit. The circuit is that at one side we have the input voltage. This is the input source. Then we have resistor R. The resistor R is then connected to a diode such that the resistor R terminal is connected to the cathode terminal of the diode. And then after the diode, we are using an external DC voltage battery of 4 volts. So please remember that this 4 volt in any way does not represent the barrier potential of the diode itself. This 4 volt battery represents an externally used DC voltage. And we want to find the output voltage. What is the output voltage available across Vout by using a 4 volt battery and by using a signal of triangular signal of 16 volt to minus 16 volts. Right, so how will we analyze this? We will analyze this circuit by again breaking our input voltage signals into two halves. First, we will analyze when we are giving a positive signal from 0 to time t by 2, and then we will analyze for the remaining part from time t by 2 to time t, negative part. Okay? So in the next slide, what we have is, in the next slide, what we see is that we are giving the positive part of the input voltage. This is V in. We have a positive 16 volt. कितना था ये positive 16 volt. So this positive 16 volt from 0 to time t by 2. It is now being available at the input. जी तो फिर क्या होगा, इसको जरा स्टडी करें जरा. Remember that the input voltage is not constant. It is varying. It is changing. It is following a linear positive slope until it reaches its maximum. And then when it reaches its maximum, it follows a negative slope so that at time t by 2, the input voltage is 0 volts. So we have to look into the fact that what happens during the positive slope and what happens during the negative slope. So at time equal to 0, this is time 0, t0. Input voltage is 0 volts, time 0 per. What will be the condition of the diode? Remember that diode is connected in this fashion. That is, we have the V out connected to the cathode and positive part of the battery connected to the anode terminal. So when input voltage, तो यहाँ पे अगर आप देख लें कि when input voltage is 0 volt, इस diode का क्या बनेगा? Will it be forward biased or will it be reverse biased?
The reverse bias.
Forward bias.
When the input is 0 volt, everybody listen carefully that when the input voltage is 0 volt, our diode will be forward biased. कैसे forward biased होगा? Because there is another battery of 4 volts which is connected at the anode terminal. This external battery will now allow current to pass through the diode. And when this current passes through the diode, our diode will look like a short circuit. And when we have a short circuit, output voltage फिर अब कितना हो जाएगा? V out कितना होगा? V out will be equal to 4 volt. V out will be equal to 4 volt. And this 4 volt will be available when input voltage, यहाँ मैं लिख रहा हूँ, when input voltage is in the range of 0 volt up till 4 volts. जब आपका इनपुट वोल्टेज 0 वोल्ट से 4 वोल्ट के बीच में रहेगा, until that time diode will remain forward biased and output voltage will be 4 volts. Therefore, if we go to the next slide, the output voltage, इस आउटपुट वोल्टेज को हम यहाँ पे ड्रॉ कर लेते हैं. अब यहाँ पे जरा आउटपुट को देख लें जरा कि एट टाइम 0 से लेके टाइम, मैं यहाँ पे टाइम लगा रहा हूँ एक टाइम t1. टाइम t1 वो टाइम है व्हेन इनपुट वोल्टेज इज 4 वोल्ट एग्जैक्टली. from time 0 to time t1, our output voltage will be equal to 4 volt exactly, because during this time diode is forward biased. Okay. Now we will study what will happen when input voltage rises from T1 up to time T2. T2 वो time है when this is T2. T2 is that time when the input voltage reaches its maximum of positive 16 volts. So if we look back to our original circuit over here, थोड़ा सा मैं erase कर दूं. So now we have V in. Now we have V in, which is more than 4 volts. Let us say that V in now is in the range of 4 volts to 16 volts. Let us assume that we have 5 volts at V in. 5 volts available at V in, 4 volt of the external battery. How can we decide whether if diode D is forward biased or reverse biased? Will our diode be forward biased or will our diode be reverse biased?
Reverse biased.
Why will the diode be reverse biased?
Sir, when we give a positive half cycle of 16 volts, and sir 16, there will act a battery, and this battery will be parallel to the 4 volt battery, and 16 minus 4 is 12 volts, and when we replace a 12 volt battery, it will be having a reverse bias condition.
तो ठीक है, concept आपका ठीक है, but if we look at the net voltage, if we take two terminals, we take two nodes. This is, let us call this node B and let us call this node A. With V in equal to 5 volt and our constant voltage source of 4 volt, the voltage appearing across the diode is such that cathode terminal has a larger voltage with respect to the anode terminal. जो आपका VA है, voltage at node A becomes larger than voltage at B. ये सब जरा गौर से समझ लें. ये मानते इस बात को? This is what is happening when V in has a larger voltage compared to 4 volt of the fixed DC battery. Voltage at node A becomes larger than voltage at B. Voltage of the A is the cathode, A is our cathode terminal, B is our anode terminal. So cathode terminal has a larger voltage as compared to the anode terminal. Hence our diode is reverse biased. ये समझ आया सबको?
Yes, sir.
So conceptually, what is happening that we are not considering up till now the current in the resistance. We are just simply analyzing, and we see that node node A is at a larger potential as compared to node number B. And with the circuit and with the direction of diode connected, it will be reverse biased. So it is easy to say that the diode is not working when the voltage ranges from 4 volt to 16 volt, because VA is larger than VB, and not just only 16 volt. when the voltage follows the negative slope and it reaches again, the input reaches 4 volts. The diode will remain reverse biased. तो अगर हम वापस चले जाएं कि जो आपका टाइम t1 है ये है 4 वोल्ट पे, टाइम t2 है 16 वोल्ट पे, और एक और हम टाइम ले लेते हैं लाइक t3, और t3 को कितने वोल्ट पे रखना है, अगेन एट 4 वोल्ट. So the input voltage start from 4 volt to 16 volt and then returns to 4 volt. During this time, the diode will be reverse biased and output voltage will be equal to input voltage. तो इसको मैं ऐसे बना रहा हूं कि at time t1 voltage rises, its maximum. इसका maximum कितना करना है?
12.
So this is 16 volts over here, not 12 volts. And then from 16 volt it returns to 4 volt. और ये जो 4 volt है ये है at time t3 and it continues like this for the remaining part. ये 16 volt कहां से आ गया?
(16) is the slope divided in time t0 to t2 of input signal.
So the 16, we get a 16 volt. When we apply 16 volt at the input, the diode becomes open circuit. And if we take a ground over here, the voltage being available is 16 volts. Therefore, we are saying that this is 16 volts.
Excuse me, sir.
जी
सर सेकंड लेक्चर स्टार्ट हो गया, 10:50 हो गया सर.
चलें, ठीक है. सो थैंक यू वेरी मच. हम फिर नेक्स्ट टाइम मिलेंगे इंशाल्लाह. रिकॉर्डेड लेक्चर अपलोड कर दूंगा मैं, ठीक है. और हमने एक नया एग्जांपल करना है नेक्स्ट लेक्चर में. ठीक है जी, अस्सलाम वालेकुम जी.
वालेकुम सलाम.